This is Lesson 5 in Unit 1, and today we'll be talking about arithmetic sequences. Our objective in this lesson is to identify, define, and apply arithmetic sequences. This is the vocabulary for this lesson. Make sure that you understand the difference between an explicit formula and a recursive formula. You will probably see those somewhere at some point on the ACT. So pause the video and write down these terms. Here is the rest of the vocabulary for this lesson. Write down this information, pause the video, and pay attention to the recursive definition at the bottom. Alright, this is the explicit formula for an arithmetic sequence, and this is what we'll be using today. This formula is on your reference sheet. Things to note. First, A with a subscript of 1 is the first term in your sequence. So when you have a sequence of numbers such as 1, 2, 3, your A1 is going to be 1. N is the term you're looking for in the sequence. The position, like the 40th term, which would be A with a subscript of 40. And D is the common difference. It always stays the same. It's what you're constantly adding or subtracting from the previous number to get the next number. Alright, here's the example we're going to do together. We're looking for the 45th term of the arithmetic sequence that begins 3, 5, 7, and so on. So we're going to be using the arithmetic sequence formula, which is AN equals A1, which is your first term, times the term you're looking for, minus 1, times your common difference. So all we have to do is plug that information in. So we're looking for the 46th term. Our first term is 3. That's our A1. We're looking for the 46th term. That's our N. And we have to multiply that by our common difference. If you look over here, to go from 3 to 5, I have to add 2. And from 5 to 7, I add 2. Common difference stays the same. Alright, one thing to pay particular attention to, if you put this information in the calculator, if you do not put this in parentheses, it'll mess up your order of operations. And you need to pay particular attention when this number is negative. Make sure you enclose it in parentheses because it'll subtract it. Alright, if I put this in my calculator, I'm going to get 3 plus 45 times 2. And I don't have a calculator with me, so I'm going to have to do it by hand. And that is 3 plus 90. So my 46th term is 93. Alright, here's one for you to practice and try. You're still using the arithmetic sequence formula. Just pay particular attention to this one because instead of your numbers increasing by a certain amount, they're decreasing by a certain amount. So what effect does that have on your common difference? Alright, here's another example we're going to do together. We want to know the number of seats in the first. Actually, it tells us the number of seats in the first 16 rows in a curved section of an arena form an arithmetic sequence. So you know that each row is changing by the same amount. It says there are 20 seats in row 1, so I have 20 seats in row 1, and 23 seats in row 2. And it wants to know, it is an arithmetic sequence, so it continues on in this pattern. It wants to know how many seats are in row 16. So you're going to be using your arithmetic sequence formula again. And we're going to be substituting our information in. So first of all, we're looking for how many seats are in row 16. We begin with A1, which is our first number in our sequence, which is 20. Then we're going to add to that. What row are we looking for? Well, we're looking for row 16, and that is our N. And our common difference. How much are we constantly adding to each term to get the next? And even though we only have two numbers, I know that I have to add 3 to get to 23. Because it tells me it's an arithmetic sequence. So that means my common difference here is 3. Alright, so I have 20 plus 15. 16 minus 1 is 15 times 3. So 20 plus 45. That means there are 65 seats in row 16. Okay, here's one for you to try. You have a trolley that stops at a certain intersection every 14 minutes. The first trolley of the day gets to the stop at 6:43. How long do you have to wait for a trolley if you get to the stop at 8:15 and at 3:20? So pay particular attention. It's not only asking you about an arithmetic sequence, it's wanting to know if you get there at 8:15, when will the next trolley after that be? Last question, I promise. A student claims that the term of arithmetic sequence 0, 2, 4, and so on is 8. You're going to have to explain to me the student's error and correct it. Good luck.